In this session, we're going to go through and talk about estimation and the use of sample sizes in statistics. I do want to start off with some information that I had in another form on another video, basically just going through and reviewing at this point why statistics are important. And so let's start off with that. Statistics are going to help us to go through and make decisions. We use statistics in business all the time. We use statistics in analyzing data and those kind of things. So they help us to go through and make decisions. And there's a lot of situations where we just do not know the answer. We need information. And there's various different ways to find that. Some people do it based on their gut feeling. Some people do it based on whether they got up and felt good that morning and those kind of things. We want to try to avoid those situations, and if we can go through and have some statistics that help us to make these decisions, then it just helps us to justify those decisions and actually may save your job or something like that. So we use statistics to help, but statistics are going to help us only if we use these tools properly. If we go through and improperly use statistics, that can cause us to make incorrect decisions and can cause some problems. We don't want to make a wrong decision, and we need to rely on more than just a gut feeling, and so that's one of the reasons why we do use statistics. So as we go through, continuing on, when we make a decision, what kind of errors can we make? Say we're going up to a Y in the road, and we go right or we can go left. Now we make a correct decision when we go right, when we're supposed to go right, we go left when we're supposed to go left. But we make an error, and I've tried to put this into a chart here. If the correct decision is to go right and we go left, that's an error. Or if we're supposed to go left, or we need to go left to get where we want to go, and we go right, that's an error. But if we go right when we're supposed to go right, that's correct. If we go left when we're supposed to go left, then that's correct. Okay? In statistics, we have that same situation. The true state of nature, the null hypothesis is true, and we fail to reject the null hypothesis. That means that another way to say that, but we don't use it in statistics, but essentially once you take out the fail to reject, that means we accept it. We don't ever accept a hypothesis in statistics. We just fail to reject it. In real life, probably that means that we accept it, but statisticians will never accept a hypothesis. They just fail to reject the null. And that sort of has something to do with the way that statistics are set up. So as a beginning student in statistics, you just have to accept that. So the null hypothesis is true, we fail to accept it, that's a correct decision. The null hypothesis is false, and we decide to reject the null hypothesis, we reject a false hypothesis, that's a correct decision. The problem comes in when the null hypothesis is true, and we decide to reject it, or when the null hypothesis is false, and we fail to reject it. Okay? We control this with our alpha level. Remember, alpha is our level of significance. And a lot of times that's going to go from, it could be 0.1, 0.05, 0.01, for example, are some of the common levels of significance. Our type 2 error is controlled in a similar way by our level of beta. That's a really hard thing to take care of, and so we generally do not, we don't set the beta level. We will set the alpha level when we are doing a hypothesis test. So we set the level of alpha, don't set the level of beta. For a fixed sample size, if we decrease alpha, if we go from 0.05 to 0.01, we decrease that level, that's going to cause an increase in the beta level. So if we reduce the possibility of making this type of error then we increase the possibility of making this type of error, is basically what that is saying. So it's sort of a, can't win situation there. You need to sort of get some sort of a balance there. So the solution to that problem is to decrease both the alpha level and the beta level. To decrease the possibility of making an error, you increase the sample size. And as we increase the sample size, that gives us more information, and that helps us to make a better decision, a more informed decision. So let me just see if I can go through and summarize this session. Basically what we want to do is we want to use our flow charts and other aids, tools, whatever. We'll talk about another way to look at some of these tests in a following session. But for right now, we just use those tools to go and help make the proper decision about which test to use. Remember, we want to use the right test in the right situation. We want to match those up. And the proper test does depend upon which situation we're going to use. And then the second thing is that the larger samples are going to give us more information, and they're going to help us to reduce the number of errors. Okay, hopefully some of that, I apologize for the technical difficulties there, but you were able to pick up some of that. I want to take just a few minutes at the end of this first video here and go through and mention a couple of things. The flow chart, that we'll go over that in the next session probably. That is given at the end of the chapter, and it allows us to go through and see how to pick out a particular test to use. Where we're moving into now is we're going to go to this, we've been doing descriptive statistics, where we go through and we describe them using the mean, the median, the mode, talking about the variables and those kind of things. Now we're going to move into a part of statistics that is called inferential. And in inferential statistics, there are two groups, or two categories. Estimation and hypothesis testing. Hypothesis testing we're going to get into in Chapter 8 and start with it through the rest of the course, or go with that through the rest of the course. And estimation, one of the things that we're going to be discussing here are going through and giving confidence intervals. And confidence intervals are important to us because if we just go through and get a point estimate, if I go through and I tell you that the average age is 36, that doesn't give you a lot of information. But if I go and I tell you that the average age of a group is from 30 to 42, a lot of times that gives you more information about what kind of people, or what kind of situation you're going to be dealing with. And so those are going to be called confidence intervals. And we're going to go through and talk about how to work with those in the next session that we're going to do on this Chapter 7. So I'm going to end this one, and we will be back in just a minute.